Welcome everyone to Knox Game Design for February 2026. My name is Levi Smith. This month I'm going to be talking about the Snake game. So this is a game that I played when I was a teenager on my old 386 through a programming language environment called QBasic that came with DOS 5 and DOS 6.22 and really influenced me a lot into getting into making games. So originally the Snake game genre came from 1976, an arcade game called Blockade by Lane Hawk at Gremlin, and you can see the picture on the left there. And then in DOS there was a Snake game called Nibbles, the one that I played, and that was, I looked into it, it was developed by Rick Radatz at Microsoft in 1990, and you can actually play that on archive.org if you go to Nibbles QBasic. Yeah, so right now I'm in DOSBox. I got a little DOS environment here, I got QBasic executable right here, so I'm just going to run QBasic. And go File, Open. We're going to select Nibbles right here. That's going to bring up the code. So yeah, I did go back and actually review the code, the same code that I looked at when I was a teenager. So this is the QBasic development environment. So you just press Shift F5 and you get it running. There's the Nibbles title screen. Press the space to continue. I'll just do one player. We're going to go 50% speed. And let's say we do want to increase the game speed. And yeah, we want color. So it takes a few seconds to load. And here it is. So basically you're the yellow snake right here. And you just eat up the numbers. Every time you eat a number, then it increases the length of the snake. And the objective is to get all the way up to number 9. Then when you get to the 9th number, then you go to the next level. So you get points for every number that you eat or collect. And you can't run into the snake body, you can't run into the wall. So you can see on this level we have a wall in the middle right there. So pretty simple game, but I think it's a good programming challenge for newer developers. So that's what happens when you die. So today I'm just going to talk a little bit about how to actually recreate that old QBasic game in a modern game development environment. I'm going to use MonoGame for this implementation. So the first step I'm calling step 0 is just to get the snake head moving around in the room. The head of the snake is going to move based on the player input, and you shouldn't allow the snake to go backward the way that it came. The room is going to be an 80 by 50 array, 80 columns by 50 rows. I'm going to use a byte array for creating the walls in the room because we're going to have different levels, and the different levels are going to have different layouts. And so if the snake hits a wall, then the game is over. The snake loses a life. Then if you lose all your lives, then the game is over. So we're going to store the room format in a byte array. 0 means that the space is empty. 1 means it's the first player snake body, and this is actually going to be a 2-player game. Or at least have the option for having 2 players. So 1 will be the snake 1 body, 2 will be the snake 2 body, and then 3 will be the arena wall. So basically, we're going to detect a collision between the head and the walls. You're going to set the is alive boolean false, and we're going to go ahead and implement 2 players at the beginning. So here it is in MonoGame. We're going to be doing this in Visual Studio. So basically, see, we have a game manager here. It's going to have the list of snakes, the 2 snake players. We're going to have an arena. That's that byte array I was talking about. The level. We're going to have some floats for updating the screen. And basically this is the constructor right here. We're going to set the level to 1. This is us setting up the game. So this is going to be true to the original QBasic. Okay, so in this game, we're going to simulate the QBasic game. So we're going to have the snake name. We got Sammy there, the head. The current length is alive, whether the player is alive or not, and then a direction. So we have an enum snake direction. So I'm going to have them start out going east. So that's the snake enum is actually defined in the snake class. So here we got an enum direction, north, south, east, and west. We got the name, length, the current row and column, direction, live, score color is alive. So here we're setting up the game. So we got player 2. Player 2 is going to be Jake. If you actually play 2 players, then it does the player 2 name is Snake, Jake. So here's our update delay, the time between amount of time between when the snake moves again. And here's where we're setting up the levels. Right now we just have the one level right here, setting up the position of the 2 snakes right there on startup. Here's what happens when on update every frame. If the update delay is less than or equal to 0, then if the snake is alive, then we're going to move the snake in the appropriate direction. That's what all the code right there is doing. Then we're checking for a collision. And basically here is the snake gliding into any walls right here. Is it not equal to 0, the current position? So here's our game 1 right here. Start up, I just used the default name. So we're setting the default size to 1600 by 1040. The cell size is going to be 20 pixels. We've got texture here for the wall, the game manager class. Here we're setting up the window size and initialization. Here's where we're loading in the texture. And basically right here's where we're getting the direction the player is pressing right there. If they're going up, then we're going to move the snake upward unless he's currently moving downward. You don't want to backtrack. That's what that's doing right there. And then we're doing the same thing for the second player right here. Here's our draw method right there. Sprite batch begins. If the snake is alive, then we're going to draw the snake. And then we're going to draw the walls. And that's basically it. So let's go ahead. It's pretty amazing that I think you can still do. Is it still F5? Yeah, so it's kind of like the same back in the QBasic. Okay, so player 1 is the arrow keys, and player 2 is the WASDF keys. So do we have collision going on right here? I'm not sure. I think I have it where if you collide into... No, at this step, I think we're just moving the characters around right here. So player 1's going to run into the top wall. Player 2's going to run to the left wall. So yeah, when they collide, then is alive gets set to false right there. So that's the first step, just to get the boxes moving around for 2 players. So step 1, add the snake body. So basically the way I'm going to do it is I'm going to have the snake body, as I mentioned earlier, be a part of the array, the wall array, just with different numbers. You could actually have the body inside of the snake class, but then you're going to have to write extra code to detect collision with the snake. So I already have to have code to detect collision between the 2 snake heads. But if you just add the snake body to the room array, the cell array, then it makes doing the collisions a little bit easier. So yeah, you want to update the draw method to draw the snake body cells. So yeah, like I said, collision will automatically work if you add the snake body to the room array. And then for this first step, whenever the head moves, we're just going to add to the end of that to the array. So this is going to be an infinitely long snake. So as usual, I got all these stored in separate folders for each of the steps. So you can kind of see what's going on in each step. So if we look at game manager, I think it's a game manager. Snake should be in the update. Yeah, so this is where we're adding it to the array right here. The Serena cell, snake I row, snake I call, get snake ID. So if it's player 1, it's going to be the player 1 snake. Player 2 is going to be the player 2 snake. So we got that going on for each of the directions that it moves. So let's play this right here. So I'm going to be controlling, you got to trust me, I'm going to be controlling both snakes here. So you can see we got the body being added to the room array. So I'm going to take player 2, the like pinkish magenta one, run him into player 1. So he died when he hit the first player's Snake 1's body. And then do the same thing for player 1. So can't do anything else now. So that's basically the second step. Step number 1, getting the body displayed, added and displayed to the screen. So here's step 2. So basically now we want to limit the length of the snake. So it's going to be, we want to track the length of the snake as a property of snake. We're going to add a list of body objects for our own column. It's required to track which cells are needed to be deleted from the arena. And then basically on every update, we're going to delete the end of the body that exceed the snake length. So we're going to remove those associated cells from the arena cell array. And the body cell index will be the tail of the snake. So it's a little bit backwards than what you would think. Whenever the head moves, that previous spot's going to be the body, it's going to be an index body plus, or it's just going to be the length of the snake. So index 0 is going to be the end of the snake, if that makes sense. If you program this, then it makes sense. So you got to think a little bit backwards with that one. So close that. Then I want to open step 2, Snake Game 02, and I'll have this out on the source code repository. So here it is right here. Can't remember if it's in Game Manager. Snakes, we're updating snakes right there. So yeah, this looks like snake body count is greater than snake length. Then the snake body position 0 gets arena cell, snake body I row, body I column gets 0. So the 0 is basically erasing the end of the snake at position index 0. Then snake body remove snake from snake body right there. Okay, so we can see right there, we've got the 2 snakes. I think they have a length of 5, I think, in this step. So we don't have infinitely long snakes anymore. And as usual, if I have this snake, they don't collide. They should die on collision. Yeah, like that right there. So now if this one collides into that one, then he dies. I don't think I have the head collision. The head is kind of a special case. The head isn't actually added to the arena array. So step 3 is adding the collectibles. This is the fun part. Add collectible on screen to pick up or eat, or to extend the length of the snake. Collectibles are represented by numerals, just like in the old QBasic game. Collectibles should not be placed on top of an existing arena walls or snake body. You don't want the snake instantly being on top of one of the collectibles. When a snake head collides with a collectible, we want to extend the snake by the length property, collectible value times 4. I looked that up in the original QBasic code, so I'm actually using the value from the original QBasic game. So as you get into the higher numbers, the 7s, 8s, and 9s, collecting those are going to extend your snake a lot longer than the lower numbers. You want to reset the collectible to a new position. Same rules. You don't want to put the collectible on top of a wall or on top of one of the snakes. We want to add score to the snake that picked up the collectible. And it's helpful to display the collectible collision cells during debug testing. Yeah, so I have a little red box right there for the collectibles because it goes over 10. It goes over 9. So let's take a look, see what it looks like. So I have a new collectible class right here. Collectible has a row and a column and a value, 1 through 9. Or actually, in this case, it could go over 9, but when you're actually playing a game, it won't go over 9. And collectible, we're going to initialize the value to 1. Got our game manager right here, as usual. And then we're going to have a setup collectible. If collectible is null, we're going to create a new collectible. Otherwise, when you pick up the collectible, we're just going to increment the value. We're going to use random rand. Gets a new random, get a random row and a random column to place it. So we're basically setting the row and column of the collectible. And then down here, check collision. If snake is alive and collectible I row equals snake I row, or collectible I row plus 1 equals snake I row, and collectible column equals snake column, and then we're going to increase the length of the snake. Then collectible value, we're going to increase the length by collect the value times the length add multiplier, which is at 4 that I was talking. If you go up here, length add multiplier, that's 4, like that. And we're also tracking score. If you die, then you get minus 10 points, which is, we add 2 zeros to the end of it, so it looks like 1,000. So then after we collect the collectible, then we're just going to call setup collectible again to change the position of the collectible. So let's run this. Okay, again, I'm playing both players here. So I'm going to have the pink one, magenta Jake, collect the 1. So you can see he gets extended by 1 times 4 for lengths. So I picked up the 2. So that extends it up to 8. Or extends it by 8. And let's go over here and pick up the 3. Oh, so yeah, when one player dies, and they both have to restart. And right now I just have this continue to increment. You can see it up there at the top, the score increments as well for the player that collected the number, and then when the player dies, they loses 1,000 points. There's no speed up or anything right now currently. And then when you go collect the last one, then it just keeps going. So the collision only works on that first number, but in practice you should never get to a 2-digit number. Okay, so it's actually starting to kind of feel like a game. Next step is adding the levels. So I kind of like recreated the levels from the original game. So you have the switch statement and the level setup code. They add the specific wall layout for each level. Added the game state enum and property to track the title, pre-level, playing, death, and game overstates. Load next level, and the snake gets the collectible with a value of 9. Move on to the next level, increment the level number, reload the level with the new layout, and set the snake length property back to the default. Transition game overstate when either player lives fall below 0. And added some helper methods to center the text and fill the rectangle around the text. So I actually downloaded this font called AC437 IBM VGA 816, which is a pretty close representation of the original DOS font. I got that from the old school PC font resource. And just a note, if you're implementing this from QBasic, one of the things that I found that the QBasic, the arena row indexes, they start at 3 because there's 2 rows at the top for displaying the score and status, and then the first row in QBasic, the indexes start at 1. So, and then the column row index started at 1 in QBasic. So if you're doing this in C# in MonoGame, then that's going to be 0. So you have to, if you're using the original layout in the QBasic game, you got to take that into consideration. So yeah, in my implementation, it starts at 0, 0. So let's take a look at step 4. Got the arena right here. So in arena, I got setup. And then I have right here, we're setting up the walls around the arena, the default. And then I got a switch statement for the level. So for case 1, we just have the walls around the arena. We don't have anything on the inside, so that we're just going to break right there. If it's level 2, then we're going to have that row in the middle right there. And then 3's got like the 4 little rings, I believe. So that's what this is doing. So I took all these values almost directly from the QBasic game, although I had to like format it for C#, but basically using the same layouts as the original game. So let's play this. And I think I added debug in this. So if I collect 1, then it moves to the next level. So sometimes you got to do things like this when you're making a game. Don't feel bad. To modify the win condition just so that you can speed along and test out the different levels. So this one's kind of tricky right here. You got to go like that. Oh, I went to the outside and it's on the inside. So let's pick up that one right there. And here. And actually, I found out that I was slightly off on the calculations because of that row and column offset. So I had to go back and offset everything by, I think, 1 row, 1 or 2 rows there. That's why there's the gaps at the top that you see here. It's really kind of hard to play 2 players. On some of these levels. Yeah, so this is just showing off all the different levels that we have in the game. Then after level 10, I think it just kind of stops. It starts repeating these levels after level 10. So after level 10, it's all the same. Okay, the next step, step 5. So we're adding sound effects now. So I recorded the sounds with Audacity. I had to set the host to Windows WAS API. Don't ask me what that stands for, but I'm sure it's on. You can look that up. Recording device, you got to set it to loopback. So basically, I recorded myself playing the original QBasic. Then I got a WAV file, and I cut the clips, put those into WAV files. I imported all those sound files into the content MG I created a dictionary of sound effects objects, and I loaded those sound effects in using content.load, using the sound effect object, or specifying the sound effect object. I think it's a template, I believe. So then you can play the sounds by referencing your sound effect in that dictionary, then calling .play. So let's check out step 5. So here's our content. I think it's under content right there. And where is it? Content MG CB right there. So you can hear it. You can see here where I had that DOS font. I loaded that in right there. I think you can like view that as a font that I was talking about earlier. So you can actually view that. That's where I loaded in this AC437 VGA font. Set it to a size of 34. It's kind of like a standard XNA MonoGame thing with this font layout file in XML. But here I got the sound dead, sound intros, sound level start, and sound pickup. Then if you go to game 1, which I just used the default name, I didn't change it for this demo. You can see right here, here's our dictionary of sounds. And here we're loading in the sounds right here. And then in Game Manager, like let's look at collectible. It's showing the game states right there. Yeah, so like here's our check collision right here. And then if we collide with collectible, then we're going to do that sound pickup play right there. So I'm referencing it from game 1 sounds. I think I have that as a static variable, I think. Yeah. So I have a static dictionary of sounds. That way I can access these sounds from any class without having to pass a reference to this sound object to all the different classes, which makes things really messy. It's nice to be able to just call game 1 sound, whatever sound I want, play. So let's take a look at it. Hopefully, oh no, the sound is off. Let's see if we can hear the sound. Oh, there it goes. Yeah, so you can hear a little bit of the sound. Might need to turn that up. Yeah, so that's sounds right there. Okay, so for the next step, step 6, which is actually the final step. I added a title screen option and pause. So screen state tracked in the game manager game state, added title screen at game start, the intro state. So one thing that I had a little bit of problems figuring out is how to add the up, down, left, and right arrows. So you have to change that character region in the sprite font file to display those arrow keys, and it's kind of tricky figuring out exactly where those are located in Unicode and everything. Option screens allow the player to input the number of players, game speed, increase the speed during play. So I made it so that you can just like press the number and not have to hit the enter key, because that's simpler to do in MonoGame. And then I changed the levels just to have 3 levels of skill, because I didn't want to have to like write a text input thing for MonoGame. So pause screen does nothing until space is pressed. First call during played method, then call the pause draw method. So you're just going to draw game pause. Oh yeah, and here's the arrow keys right here. So I had to do some research to figure out exactly. So the arrow characters like start at 8592 in Unicode and end in 8595. So I just added a second character region to track those. And actually this character region should be, I think, over that one right there. That's a typo. So let's take a look at it. Snake Game 06. So what I think is cool about this is I could pretty easily modify this to use gamepad input to play a Nibbles clone. So here's my title screen right here. I may have not gotten the sparkles exactly correct, but I think I got it pretty close. So I just called it Knox Game Design Snakes, created in MonoGame 2026. Based on QBasic Nibbles by Rick Raditz at Microsoft 1990. So I'm not claiming any ownership to the Nibbles game. This is just an educational demo here. So, but yeah, like I was saying, the hardest part was like figuring this, how to display these stupid arrow keys right here. But I finally got it right. So press space. How many players? So like I said, you just press 1, and then instead of entering 0 to 100, you just like, if I want to be expert, I just press 2. Makes things a lot simpler. Then increase game speed. Now let's go ahead and increase game speed. And I didn't add the option to do monochrome, so I don't know. Got kind of burnt out. I was like, okay, I'm done with this. So here we go. This is the expert level. I'm only doing 1 player now. But we got the sounds, and we got the snake going, and I think it really feels like the original Nibbles game in QBasic. But this is running. This is a real Windows executable. And it does feel a little bit more smoother. Runs a little bit more smoothly. Because the original Nibble games was actually all text-based, and they used like the extended DOS characters, and they did some tricks. So that's why I couldn't do an exact clone from the QBasic. That would have made things really easy. But the tricks that he did when he made this game made it so it wasn't as easy just to copy the code. So it's like a true re-implementation, or a true remake, or a true port of the Nibbles game. But I think it's pretty cool because you can actually take this and play it on Windows or any Windows compatible device, and really feels true to the original. Yeah, just go back out. You can see here, there's that title screen right there. So I do have the different, what is this, game 1? In game manager, this is one of the things I kind of struggled a little bit with. So here's the options right here. So I keep track of all the options in one option object. Here's option CS. So here's the number of players, skill level, speed, increased speed. So that kind of gets used by the game manager to track all that. And here's like the time between frames for each of the speed levels. But let's go back to game manager. And here's our game state. So I have a public game state. So you're either in title, options, playing, pre-level, player dead, game over, or paused. So the one thing that isn't quite right about this is I would have liked to have a display manager class for this that just did all the drawing. But as you see down here, I have like draw tech, draw centered, fill cells. Where is it at? So here's like all the drawing code for draw plane, the plane state of the game. It's all in draw plane in the game 1 class. If we go up here, draw option, here's all the drawing code for the option screen. Here's the title, draw title sparkle, draw the sparkling title screen. Or that's actually a helper, I believe. Yeah, the sparkle's just displaying the little stars around it. So draw title, all the drawing code just for drawing the title screen. Draw pause, here's all the code for drawing the pause screen. And draw game over, here's all the code for drawing the game over screen. And draw play when the player dies, it's all right there. Draw pre-level. So for each of these states, I have a draw method. So then right here in my draw method, the main draw method, then I have a switch game manager game state. So if it's title state, draw the title. If it's option state, draw options. Pre-level, draw pre-level. The only one that's different is like the pause. So I draw the plain screen, then I draw the paused message over the plain screen. So you can actually still see the plain screen in the background. So ideally, I'd have all this into a display manager class, but I found it became a headache trying to pass the sprite batch object back and forth and all that good stuff. So I was like, yeah, I'm just leaving it in game 1 for now. And it seems to work. Very similar to that in the update method. This is kind of a mess right here. This would need to be cleaned up a little bit. So I have game manager game state. If it's in title, here's where we're doing the title stuff. If they press space, then we're going to move to the options state. If we're in options, we're going to get the number of players. Wish I could make this a little bit. I can't scroll over. This is kind of getting squished down. I'll make it a little bit smaller. Yeah, so for each state, we have different inputs, and we have it all kind of like here's another game state for pre-level. If they press space on pre-level, then we're going to go to the plain state. The player's dead, and they press space, then we're going to go to the plain state, and we're going to play the level start sound. So all the inputs are in game 1 class, which isn't good. There should probably be a separate input manager. I should really have a screen. I've done this before. I'd have like a screen object, and the different game modes would extend the screen object, and each screen would have its own input handler and display methods and its own update. But since this is just a demo, I didn't do that. Yeah, so that's basically it for the Snake game. I hope everybody found it entertaining, educational. Maybe you got something from it, but if anybody out there is like an old school QBasic programmer like me, then it's kind of neat to be able to go back and implement one of these games. And I did want to mention, I got handouts, Knox Game Jam 2026. I've been putting these around town, knoxgamedesign.org. Go check out the site. Yeah, Knox Game Jam 2025. I got it. If you scan the QR code right there, then it'll take you to the Knox Game Design website. Has the same information. It also has like the meeting location. We're planning on just doing Panera Bread again on North Peters Road. It's going to be 7 p.m. on April 3rd, 2026. UTC -4 Eastern Time, Eastern Daylight Time. That isn't University of Chattanooga. Hope nobody gets confused about that. But yeah, UTC -4 is Eastern Time for Daylight Savings Time. But it's kind of the same thing we do every year in April. Make a game in 48 hours, use any game engine or library. Here's some suggestions like Unity, Godot, Unreal, Game Maker, MonoGame, SDL, or Allegro, or whatever you choose to use. Your game is your prize. We're going to use Itch again for submitting our game, so you can go there and submit. Go ahead and go sign up, and then when it starts, and you can submit your game. During the kickoff meeting, we're going to put the themes on a wheel again. We're going to spin the wheel to get the theme. Had a lot of fun doing that last time. All are welcome to attend, even if you don't plan on making a game. If you just want to come out, hang out with us, talk about making games, or if you have something you want to show off or show the group, we welcome that as well. And as usual, there will be no space for developing games at the site. I think they close around 9, so usually we got like an hour or two before we get kicked out. But forming teams is encouraged if you choose to work on a team. So I usually just do it solo, but if you want to make a team, you can do that. So anyway, appreciate everyone out there listening and watching.